Michael KC9PHK here on behalf of the Clay County Area Amateur Radio Club, covering the 2020 to 2024 Extra Class Question Pool. This is video number 5 in this series, covering subelement E5, Electrical Principles. 4 exam questions come from the 4 groups located inside subelement E5. We're covering only the questions and the correct answers in an effort to keep the videos as short as possible. E5A covers resonance and Q, characteristics of resonant circuits, series and parallel resonance, definitions and effects of Q, half-power bandwidth, phase relationships in reactive circuits. E5A01, what can cause the voltage across reactances in a series RLC circuit to be higher than the voltage applied to the entire circuit? Answer is resonance. E5A02, what is resonance in an LC or RLC circuit? Answer is the frequency at which the capacitive reactance equals the inductive reactance. E5A03, what is the magnitude of the impedance of a series RLC circuit at resonance? Approximately equal to circuit resistance. E5A04, what is the magnitude of the impedance of a parallel RLC circuit at resonance? Approximately equal to circuit resistance. E5A05, what is the result of increasing the Q of an impedance matching circuit? Matching bandwidth is decreased. E5A06, what is the magnitude of the circulating current within the components of a parallel LC circuit at resonance? It is at a maximum. E5A07, what is the magnitude of the current at the input of a parallel RLC circuit at resonance? Minimum. E5A08, what is the phase relationship between the current through and the voltage across a series resonant circuit at resonance? The voltage and current are in phase. E5A09, how is the Q of an RLC parallel resonant circuit calculated? Resistance divided by the reactance of either the inductance or capacitance. E5A10, how is the Q of an RLC series resonant circuit calculated? Reactance of either the inductance or capacitance divided by the resistance. E5A11, what is the half-power bandwidth of a resonant circuit that has a resonant frequency of 7.1 MHz and a Q of 150? Answer is 47.3 kHz. E5A13, what is the half-power bandwidth of a resonant circuit that has a resonant frequency of 3.7 MHz and a Q of 118? Answer is 31.4 kHz. E5A13, what is the effect of increasing Q in a series resonant circuit? Internal voltages increase. E5A14, what is the resonant frequency of an RLC circuit if R is 22 ohms, L is 50 microhenries, and C is 40 picofarads? Answer is 3.56 megahertz. E5A15, which of the following increases Q for inductors and capacitors? Lower losses. E5A16, what is the resonant frequency of an RLC circuit if R is 33 ohms, L is 50 microhenries, and C is 10 picofarads? Answer is 7.12 megahertz. Going on to E5B, time constants and phase relationships, RL and RC time constants, phase angle in reactive circuits and components, admittance and susceptance. E5B01, what is the term for the time required for the capacitor in an RC circuit to be charged to 63.2% of the applied voltage or to discharge 36.8% of its initial voltage? 1 time constant. E5B02, which letter is commonly used to represent susceptance? Answer is B. E5B03, how is impedance in polar form converted to an equivalent admittance? Take the reciprocal of the magnitude and change the sign of the angle. What is the time constant of a circuit having two 220 microfarad capacitors and two 1 mega ohm resistors all in parallel? 220 seconds. E5B05, what happens to the magnitude of a pure reactance when it's converted to a susceptance? It becomes the reciprocal. E5B06, what is susceptance? That is the imaginary part of admittance. E5B07, what is the phase angle between voltage across and a current through a series RLC circuit if XC is 500 ohms, R is 1 kilo ohm, and XL is 250 ohms? 14.0 degrees with the voltage lagging the current. E5B08, what is the phase angle between the voltage across and the current through a series RLC circuit if XC is 100 ohms, R is 100 ohms, and XL is 75 ohms? Answer is 14 degrees with the voltage lagging the current. E5B09, what is the relationship between the AC current through a capacitor and the voltage across a capacitor? Current leads voltage by 90 degrees. E5B10, what is the relationship between AC current through an inductor and the voltage across an inductor? Voltage leads current by 90 degrees. E5B11, what is the phase angle between the voltage across and the current through a series RLC circuit if XC is 25 ohms, R is 100 ohms, and XL is 50 ohms? Answer is 14 degrees with the voltage leading the current. E5B12, what is admittance? The inverse of impedance. E5C covers coordinate systems and phasors in electronics, rectangular coordinates, polar coordinates, and phasors. E5C01, which of the following represents capacitive reactance in rectangular notation? Answer is negative JX. E5C02, how are impedances described in polar coordinates? Answer is by phase angle and magnitude. E5C03, which of the following represents an inductive reactance in polar coordinates? A positive phase angle. E5C04, which coordinate system is often used to display the resistive, inductive, and/or capacitive reactance components of impedance? Answer is rectangular coordinates. E5C05, what is the name of the diagram used to show the phase relationship between impedances at a given frequency? Phasor diagram. E5C06, what does the impedance 50 minus J25 represent? 50 ohms resistance in series with 25 ohms capacitance reactance. E5C07, where is the impedance of a pure resistive plot plotted on rectangular coordinates? On the horizontal axis. E5C08, what coordinate system is often used to display the phase angle of a circuit containing resistance, inductive and/or capacitive reactance? Polar coordinates. E5C09, when using rectangular coordinates to graph the impedance of a circuit, what do the axes represent? The x-axis represents resistive component and the y-axis represents the reactive component. On E5C10, which point on figure E5-1 best represents the impedance of a series circuit consisting of a 400 ohm resistor and a 38 picofarad capacitor at 14 megahertz? Correct answer is point number 4. E5C11, which point on figure E5-1 best represents the impedance of a series circuit consisting of a 300 ohm resistor and an 18 microhenry inductor at 3.505 megahertz? Answer is B, 0.3 on the figure. E5C12, which point on figure E5-1 best represents the impedance of a series circuit consisting of a 300 ohm resistor and a 19 picofarad capacitor at 21.200 megahertz? Answer is 0.1. E5D covers AC and RF energy in real circuits, skin effect, electromagnetic fields, reactive power, power factor, electrical length of conductors at UHF and microwave frequencies, and microstrip. E5D01, what is the result of skin effect? Answer is, as frequency increases, RF current flows in a thinner layer of the conductor closer to the surface. E5D02, why is it important to keep lead lengths short for components used in circuits for VHF and above? To avoid unwanted inductive reactance. E5D03, what is microstrip? Precision printed circuit conductors above a ground plane that provides constant impedance interconnects at microwave frequencies. E5D04, why are short connections used at microwave frequencies? To reduce phase shift along the connection. E5D05, what is the power factor of an RL circuit having a 30-degree phase angle between the voltage and the current? Answer is 0.866. E5D06, in what direction is a magnetic field oriented about a conductor in relation to the direction of electron flow? Answer is in a circle around the conductor. E5D07, how many watts are consumed in a circuit having a power factor of 0.71 if the apparent power is 500 VA? Answer is 355 watts. E5D08, how many watts are consumed if a circuit having a power factor of 0.6 if the input is 200 volts AC at 500 amperes? Answer is 600 watts. E5D09, what happens to reactive power if the AC circuit that has both ideal inductors and ideal capacitors? It is repeatedly exchanged between the associated magnetic and electric fields but is not dissipated. E5D10, how can the true power be determined if an AC circuit where the voltage and current are out of phase? By multiplying the apparent power by the power factor. E5D11, what is the power factor of an RL circuit having a 60-degree phase angle between the voltage and the current? Answer is 0.5. E5D12, how many watts are consumed in a circuit having a power factor of 0.2 if the input is 100 volts AC at 4 amperes? Answer is 80 watts. E5D13, how many watts are consumed in a circuit consisting of a 100 ohm resistor in series with a 100 ohm inductive reactance drawing 1 ampere? 100 watts. E5D14, what is reactive power? Reactive power is wattless, non-productive power. E5D15, what is the power factor of an RL circuit having a 45-degree phase angle between the voltage and the current? Answer is 0.707. And that will conclude this video. Thank you for joining us. Don't forget to like this video, subscribe so you're getting additional updates, and follow this playlist as you'll find other extra class videos specifically for these slides.